Hi, this is Module 2, Lesson 10, Algebra 1. We are form follows function, so we're wrapping up everything we've done from this module. Um, so here's the first page is just talking about some of the things that we've learned concerning linear functions and exponential functions. So we've got the y equals mx plus b form right here. And here we've got the point slope form. And then we've talked about a recursive formula. So those are just reviewing what we've already learned. As far as exponential goes, we have explicit and we have recursive. So those are the two, just reviewing for Module 1 there. You can look at those more on your own. Okay, so basically what this is deciding which of those you'd want to use and what kind of information you have when you do those. So let's go ahead and decide which problems we would use what for and go from there. So first of all, we want to write an equation for the problem. So in his job selling vacuums, Joe makes $500. Just going to mark some of this information. $500 each month plus, it's a keyword there, $20 for each vacuum he sells. Write an equation that describes Joe's monthly income as a function of the number of vacuums sold. So we know we're going to do a function income I. So I equals, well, he makes $500 a month. So each month he's making $500 plus, here's that plus, $20 for every vacuum he sells. Well, N is the number of vacuums he sold. So if it's $20 for every vacuum, that would be a multiply. So this equation is set up in linear form, starts with 500, gets $20 every vacuum. That's repeated multiplication. Okay, so name the form of the equation you wrote and why you chose that form. Well, this would be a slope intercept. If we go back to that front page, I'm just going to scroll back up here so you can see, since it's linear, either a slope intercept, point slope, or recursive. Well, we have a slope, we had a y-intercept, so it is a slope-intercept form. Slope-intercept, starting point, that's our y-intercept, and we have our slope. And this function is linear. And if we're selling vacuums, then we have to be discrete. You can't sell half a vacuum. All right, next. Number 2, write the equation of the line with the slope of -1, and it goes through the point of -2, 5. Well, this would be slope point form. So I'm going to go ahead and put that on here. Slope point form, because I have a slope and I have a point. So we know that that's y equals our slope, -1, that was last lesson, times x minus my x coordinate, which is a -2, so that turns into a plus 5, my y coordinate. So this function is also linear. We don't have any exponents going on. And this one would be continuous because there's no situation that's telling us we have to do dots. All right, let's see what our next one is. Next one, write the equation for the geometric sequence with a constant ratio of 5 and a first term of -3. Well, constant ratio means we can do it both ways. So I like to do explicit. So if I use my first term of -3, constant ratio means I'm multiplying by 5 repeatedly So that'd be 5 to the x. Or actually, x minus 1, because I have a first term, not a zero term, a first term. So if I did this one, I would say explicit is the form that I used, because I like to be able to just write them out that way so I can plug in any number. Now, technically, they said our first term is -3, and if I'm doing a constant ratio, f of n minus 1 times 5. This would be recursive. Now, when I go to answer my questions down here, we are exponential because we've got the exponent. We know we're multiplying, constant ratio. This function would actually be discrete because it's telling us a first term and it's telling us what to do to find the next term. So we would have a first term, a second term, a third term, a fourth term, a fifth term, and it's not technically connecting them. So we could use either equation, but it does mean it's discrete. Number 3, write the equation for the function graphed below. All right, well, let's see if we can find a couple of points on this line so that we can use them. Looks like I have a point at 8, 3. 8, 3. I'm going to go ahead and put that here. 8, comma 3. And it looks like it crosses again at 4, comma 0, right there. So 4, comma 0. So if I figure out on here, oh, you know what? And I've got a y-intercept right here. So I have a y-intercept of -3, and I can figure out my slope. So 3 minus 0 over 3 minus 0 over 8 minus 4. So that'd be 3/4. So my slope is 3/4. So I can actually write my equation as y equals 3/4 x minus 3. So I did slope intercept. Now I could have done slope point form if I had chosen not to do this y-intercept right there, but I chose to do the slope intercept, so I'm going to stick with that. This is a line, so it is linear, and it's connected, so it is continuous. Next, population of the resort town of Java Hot Springs in 2003 was estimated to be 35,000 people with an annual rate of increase of about 2.4%. I want the equation that models the number of people in Java Hot Springs, with T being the number of years from 2003. So let's see, I'm going to do my f of x equals, well, my starting term is 35,000. And that would be my 0 because I'm starting in 2003, and the t is the number of years from 2003. And since it's a percentage, I know I'm going to multiply by 100% plus that. So 1.024 is 102.4%. And then I need to put it to the t power. And since this is the 0, I don't need to have a minus anything. So here I did explicit because of, that's how I like to write my equations, so I can plug in any number. We have an exponent, so it's exponential. And we're talking about people, so it is discrete. So can't have half a person since we're talking about population. I suppose you can argue that you will have multiple points throughout the year, but I like to go with the basic of can't have half a person, we've got to do dots for whatever points we're going to use. All right, next. Jessica's science fair project involved growing some seeds to see what fertilizer made the seeds grow fastest. So one idea she had was to use an energy drink to fertilize the plant. She thought if they make people perky, they might have the same effects on plants. This is the data that shows the growth of the seed each week of the project. So if I look at my jumps here, I need to know if it's an adding or a multiply. Well, if I do the adding, it's a plus 1.2. If I add 1.2 again, hey, look at that. I'm at 4.1 plus 1.2, I'm at 5.3. So I know this one's going to be linear because it's a line there. Now, what I notice is I have a slope. So this is my slope. And I also have a point. So this is going to be slope point form. So then I can put, let's see, height equals, my slope is 1.2, and then my weeks minus 1, because that's my x here, plus 1.7. I could just use that information that I have here and make my variables and go from there. And this one would be continuous because it is constantly going to grow. All right. Equation gives us information we can use to graph a function. Pick out the important information given in each of the following equations and use it to information to graph it. Well, what do we know? Well, this is y equals mx plus b form. So I know my y-intercept is 0, -5. I can tell from this also my slope is 1/2. I know this is linear and it's explicit, so I know it's continuous. So let's go ahead and graph this. 0, zoom in just a little bit more on this guy. 0, -5, right there. And 1/2 is up 1 over 2, up 1 over 2, up 1 over 2, and so on. So this is going to be my graph. So I was able to go ahead and, whoop, there we go. All right. So see how we can come up with that information and be able to graph accordingly. All right, so let's scroll up here. How about this one? What do I know? And what helps me graph it? Well, there's an exponent, so I'm going to put exponential on here. It's not recursive, so I'm going to do continuous. I also know that my y-intercept is 0, 1, because if I put a 0 in there for my x, my answer would be 1. So 0, 1. And then I have a common ratio, because what am I, oh, not ration, ratio, because I'm repeating multiplication of 2 each time, so my common ratio is 2. So if I start with, zoom in quick, 0, 1, and I'm going to go ahead and plug a 2 in for that, so 2 to the second, oh sorry, 2 to the first, 2 to the first is 2, 2 to the second is 4, 2 to the third is 8, and then I'm going to be off my list. If I go 2 to the negative 1, it would be half. There we go. I have my exponential function right there. Let me zoom this back in a little. There. All right. Next one. What do we know? Well, from this one, we know this is linear. We also know it's continuous because it's explicit. It is slope point form, so I know there is a slope of -2 and a point on the line is, let's see, it's a positive 6 here, so that means negative 6 and positive 8, as I've subtracted my x. So if I'm going to go from negative 6, comma 8, that's way up here, and I'm going to go a slope of negative 2, I'm going to go down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1, and keep going. So here is my graph for this one. Nice. So see how we can put this all together on here. All right, so this one, what do we know? Well, let's see. We know it's recursive, which means it's discrete. So I'm only going to have dots on here. Let's see, I'm adding 1 each time, so that makes it linear. So I know my first term is negative 5, which means it's 1 comma negative 5. And I also know that my rate or slope is going to be 1. So if I start at 1, negative 5, I'm going to start right here, and I'm going to go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, and just keep going. And there we go. I have made, oh, undo. We do not want to connect those, do we? We have to put all those dots because this is discrete. Good catch there. All right. And that's it. We have worked through basically the review of Module 2. Great job. See you next time.